Welcome to this video lecture on the subject transmission lines and antennas. In this lecture, we are going to discuss about ground wave propagation. So for radio wave propagation, there are many types are available. So in this, we are going to discuss about the ground wave propagation. So here the electromagnetic waves travels along the Earth's surface. It is one of the primary modes of radio wave propagation, especially for low and medium frequency signals. So ground wave propagation is significant for communication over distances where LOS propagation may not be feasible, such as in cases where the radio waves need to travel beyond the horizon. So the concept of radio wave propagation here, when a radio signal travels along the Earth's surface, the wave doesn't just travel straight through the air but rather follows the contours of the ground to some extent. So this type is particularly important for low frequency signals below 3 MHz, which tend to be absorbed or refracted by the ground. So it is the ideal radio wave propagation for short distance communication during the daytime. It is applied in local radio broadcasting, radar, amateur radio communications. And in ground wave propagation, the transmitting as well as receiving antennas are on the Earth's surface, offering multiple paths for communication. When the transmitting antenna and receiving antenna are in the line of sight, then the direct path exists. A wave that propagates between the antennas at the line of sight is called as the direct wave. The direct wave is the component of the ground wave. These are the three components of ground waves. One is surface wave, direct wave, and earth reflected wave. So the components of the ground wave that uses the earth surface as the wave conductor, and the component of the ground wave that propagates through the shortest distance between the 2 points on the earth surface. So it is the direct wave. And the component of ground wave that gets reflected from the earth surface and then travels towards the receiving antenna is the earth reflected wave. And next we are going to see about the characteristics of ground wave propagation. So first one is the frequency range. So it is most effective at low frequencies, medium frequencies, and high frequency up to around 3 MHz. So these frequencies can follow the Earth's surface for long distances, especially at night when ionospheric effects are reduced. And next is the attenuation. As the wave travels along the ground, it experiences some attenuation. The rate of attenuation depends on factors like frequency, conductivity of the ground, and terrain. For example, seawater provides better conductivity than dry land, allowing for more efficient ground wave propagation. And next characteristic is the range. The range of ground wave propagation can extend up to several hundred kilometers depending on the frequency and environmental factors. So for very low frequencies, ground waves can propagate over thousands of kilometers, and while for other high frequencies the range is shorter. And terrain impact. The type of terrain can also affect the ground wave propagation. Flat conductive terrain like oceans allows better signal propagation compared to mountain or highly uneven terrain where the signal may be obstructed. And next is the nature of the ground. So ground waves, especially surface waves, are influenced by the nature of the ground above which the signal propagates. So the signal attenuation is dependent on the factors like ground conductivity, topography, and dielectric constant. So the ground penetration and surface conductivity are very important. So at the low frequency range, so distance up to 100 meters have a certain effect on signal transmission. So ground penetration of low frequency ground waves is high and affects the surface conductivity as well. So next is the polarization. The antenna polarization is great importance in ground wave propagation. So vertical polarization is better suited for ground wave than the horizontally polarized antennas. So because of the vertical polarization, medium and long wave radio stations generally employ the self-radiating vertical transmitting antennas. And next is the weather. The weather plays an important role in the losses incurred in ground wave propagation. So dry and sandy signal propagation paths are not suitable for ground wave. The moisture content in the atmosphere can be helpful to ground wave propagation. So next is the signal frequency. So signal attenuation is depends on the signal frequency. As the frequency increases, the losses increase, and this phenomenon limits the ground wave propagation above 3 MHz. So other factors are density of the ionization of the layer and the angle of incidence at which the wave enters the surface. Applications of ground wave propagation. So in the AM radio broadcasting, AM radio stations operating in the medium frequencies 532 1700 kilohertz, so uses the ground wave propagation to cover areas beyond the line of sight, especially during night time when ionospheric propagation is less reliable. And navigation systems, low frequency navigation systems such as which one used by maritime and aviation industries, and military communication. So for long range communication areas where other propagation methods are not effective, so ground wave propagation is employed. So let's take the assessment. So first one is the ground wave is always polarized. So which is the correct answer? The vertical or horizontal, either vertical or horizontal, neither horizontal or vertical. So the option is A, vertically polarized. Ground wave propagation is used for signals up to 2 MHz, 2 GHz, 30 MHz, 30 GHz. So the answer is option A, 2 MHz. So thank you for listening this lecture.